I just want to make this a kind of a footnote to part A of this problem. And you'll see this reflected in the scoring guidelines. So in case you looked at that, I want to answer this particular question. And that is that when we're finding the interval of convergence, the first way we did this was using the geometric series formula that the geometric series will converge when the absolute value of r is less than 1. And we set up and we solved that. If we solved it that way, using the geometric series test, we don't need to test the endpoints. However, whenever we find the interval of convergence using the ratio test, that will always only include the open interval, for example in this case between -2 and 0. It doesn't give us any information about the endpoints. And so what I would like to do now is to kind of go through what we would have to do if we were testing we're trying to find the interval of convergence using the ratio test. So if f of x is 1 plus x plus 1 plus x plus 1 quantity squared, etc., then the general term would be x plus 1 to the nth. And we could say that the series would be written as the sum from for n equals 0 to infinity of x plus 1 to the nth power. So the way we're going to test the endpoints is, in this case, we want to go for x equals -2 to x equals 0. Well, what happens at x equals -2? When I plug in x equals -2, then I'm going to get -2 plus 1, which is just -1. And so I have the series sum for n equals 0 to infinity of -1 to the nth. And because that series does not, because the sequence does not approach 0, does not have a limit of 0 for the limit as n approaches infinity of the nth term, which is -1 to the nth power, does not equal 0. So the limit as n approaches infinity of the nth term does not equal 0. And so therefore the series diverges at x equals -2, and -2 is not included in the interval of convergence. All right, now we're going to test the other endpoint, which is x equals 0. And at x equals 0, we're going to get 0 plus 1, which is just 1. And so we would have the sum for n equals 0 to infinity of 1 to the nth. And that diverges also because of the nth term divergence test. The limit as n goes to infinity of 1 to the n, as n goes to infinity, 1 to the n does not approach 0, and so it diverges at the other endpoint as well. And so in this case we would have had the correct answer, and if you notice in the scoring guidelines it didn't ask you to test the endpoints, and in this case we would have been correct because of the just by the fact that this was a geometric series and we used that test correctly there, we would have gotten the right answer. But in general, when we're not working with a geometric series and we're using the ratio test, then after we're done finding the interval of convergence, we still have to, or part of the interval of convergence is testing the endpoints. The ratio test will not give us any information about the endpoints, and we're going to have to look at each of those series that are created when we substitute the endpoints in. We're going to have to look at them using our convergence tests and determine whether the particular series converges at those endpoints or not, and include or not include the endpoints into the interval of convergence. I hope that makes sense. We'll see more examples of those in other problems that we're doing. But I did want to point that out in case you saw that in the scoring guidelines, then it would be important to understand why that works the way it does. Thanks.